Now let's go to the Big Bang and that first core, that dense core, to see how this law of probability plays out. So when we examine the Big Bang, it wasn't really an explosion, it was more of a rapid expansion. So you had this very hot core in the beginning. This core, you know, we don't know exactly the temperature of it, but it was in the trillions and trillions and trillions of degrees. That's how hot it was. Now suddenly, this core begins to rapidly expand. Do you know the rate of expansion that happened? Let's borrow a quote from Stephen Hawking, you know, who was a leading atheist in the world. Let me share with you his quote. He says, if the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million, we'll examine how small that is, the universe would have recollapsed before it reached its present size. If that rate, that amazing rate of expansion, that rate of expansion was faster than the speed of light. Space, that core, you know, which had space, started to expand faster than the speed of light. It doubled in size 90 times in such a fast portion of time. This rate of expansion, if it was a little bit smaller, just a tiny fraction smaller, the universe would have recollapsed. It couldn't reach its present size. On the other hand, he says, if it had been greater by a part in a million, if it was just a little bit faster, the universe would have expanded too rapidly for stars and planets to form. Do you know how this number that he gives us, if the universe was expanding at a rate that is smaller than 1 part in 100,000 million? Do you know how small this number is? Roger Penrose, who's an Oxford professor of math and physics, he gives us an example of how small this is. He says, if I give you a pin, I give you a dart, and you have a target, you're asked to take this dart and throw it at the target. Let's say that board, that canvas, that target board is the universe, is as big as the universe. And you take this dart and you're blindly shooting it. Now every point on that canvas, which is as big as the universe, your dart, every point that it lands on would create a different universe or no universe at all. Most of the dots, if the pin would land at it, it could not create or generate a universe. Now, what are the chances of that dart, of that pin landing on a point that will create this universe that we have? The characteristics of this universe. How small is that chance? You know what he says? He says if every particle in the universe would be a zero, you would put a zero next to that particle. We human beings, how many atoms do we have? Just one single person on average, how many atoms do you have? 7 trillion atoms. 7 trillion, just one body. Imagine how many atoms and subatomic particles, right? And electrons and protons and neutrons there are in the universe. He says this number, this chance is so small because how do you write a number? If you want to write 1%, how would you write that number? You would write 0.01. That's 1%, right? He's trying to give us an example of how small this chance is that the universe just randomly landed where it is. Let's take this one. He says if next to every particle in the universe you put a zero, and you keep going and going and going, if you used every particle in the universe to put more zeros, you still couldn't capture how small this number is. It's so small, and I'll write it to you. It's 1 to the power of 10 to the power of 10 to the power of 123. 1 in that number. That's how small the chance is that this universe just randomly expanded the way it did. Do you see how small this number is?